Okay. Bismillah ar-Rahman ar-Rahim. Good morning, everyone. My name is Pakinam Isawi. I will be moderating the Young Water Inventor session today. The Young Water Inventor competition is made for the STEM schools student who completed the water-related science project. It is sponsored by the Ministry of Water Resources, GIZ, the National Bank of Egypt, and the FAO, the Food Agriculture Organization by the United Nations. Before we proceed, I would like to thank every teacher, parent, and young the inventor who had the chance to join us today. It's a really hard effort, and you did it. Today at the Cairo Water Week 2024 for the 7th edition. These inventors competed among 243 students with 123 projects, and they were able to make 5 projects here to the final round of the Cairo Water Week Young Water Inventor competition. Today we have 10 students from different schools. We have Alexandra STEM School, we have El Ismailia STEM School, Obor STEM School, and the Red Sea STEM School. Before we start, let us welcome our technical committee panel. We have Professor Ines Muhammad Ali Abu Talib, the chairman of this session. She's a professor at the Wastewater Treatment Technology and Environmental Studies at the National Research Center. We have Professor Salim Gaber, Professor of Environmental Chemistry and Head of the Quality Control and Assurance Department, Central Laboratory for the Environmental Quality Monitoring, National Research Center. We have Professor Safa Muhammad Izzat, Professor of Microbiology and Head of the Microbiology Department, Central Laboratory for the Environmental Quality Monitoring, National Water Research Center. We have Professor Ziad Muhammad Ali Khalifa, Chemical and Environmental Engineering Department, Faculty of Engineering at the British University. And then we have Dr. Muhammad Yaqub, Assistant of the FAO Organization Representative. We have Engineer Mahmoud Ali from the Irrigated Agriculture Specialist NDWM Program, Ensure Cluster, the GIZ. And myself is Pakinam Isawi. I'll be moderating today's session. So before we start, we would love one of our beloved student, Habiba Tariq, to present what is the STEM school and what their role here. Can you welcome Habiba Tariq?
أول واحدة.
You don't need this slide.
STEM, science, technology, engineering, and mathematics schools here in Egypt are pioneering a new model of education in order to empower youth to solve local challenges and to drive progress. These specialized boarding schools are here to empower critical thinkers, innovators, and problem solvers through immersing them in rigorous STEM learning. Their curriculum basically focuses on hands-on inquiry-based learning. So they complete through project-based learning 5 capstone projects, solving Egypt's grand challenges, and following the engineering design process, mentored by teachers and evaluated by professors, so they can gain communication, collaboration, and critical thinking skills. Last but not least, STEM students today are tomorrow's leaders and change makers.
Thank you, Habiba, so much. Okay, how our session is going to be defined today. So each group of students from STEM school will present from 10 to 15 minutes. After that, we have 5 minutes discussion by the panel. The panel then will put their grades for every group, and then at the end of the session, we're going to collect these from the sheets from the judges and put our ranking for the students. Okay, so please let me welcome the first STEM school, Obor STEM School, and their title is Sustainable Agriculture Irrigation Using Bio-Based Hydrogel. Please welcome with me Yusuf and Yassine.
تمام. اوكي.
يلا.
Hello everyone, my name is Yassine Yasser and Yusuf Abdelal. We are from Abur STEM School. Our main aim is to help the society to achieve a sustainable agriculture irrigation by using a material that is still under development in agriculture. And this material is the hydrogel. Our project is not just using every drop of water wisely, but also reclaiming the sandy soil areas. There are two main problems that affect the agriculture. The first one is the water scarcity, and the second one is a large number of areas which are sandy soil areas, and they are unsuitable for agriculture. In case of the water scarcity, we use about 70% of the total annual water supply just on agriculture. 40% of this water is lost in the environment because of various things such as insufficient irrigation and evaporation rates. In case of the lands which are unsuitable for agriculture, it represents about 31% of the total land areas. And in case of Egypt, it represents more than 70% of the total land areas. So imagine if we can reclaim all these lands by just using our hydrogel. There are also existing solutions for our problems, such as the sprinkler irrigation and subsurface drip irrigation, but the common disadvantages between them that they have a high cost and they are not that efficient in reclaiming the sandy soil areas. And also, in case of sprinkler irrigation, it is sensitive to wind, and in case of subsurface drip irrigation, it has a risk of clogging. So, in order to overcome all these disadvantages, we can use our hydrogel as a dependable material for agriculture.
The hydrogel has various applications like biomedical, drug delivery, and the application that is still under development is agriculture. In case of agriculture, the hydrogel is a network of polymers which can be imbibed by the water and nutrients and then release it slowly into the soil. To make a suitable hydrogel for the agriculture, we should consider the biodegradability, biocompatibility, and cost efficient of this hydrogel. So, we made a grafted bio-based hydrogel from the starch and acrylic acid. And in figure 4, we can observe the network of our hydrogel before imbibition, which is the left, and after imbibition in the right. Okay, our methods begin by gelatinizing the starch at 80 Celsius temperature, and then we add the neutralized acrylic acid, which neutralizes by the potassium hydroxide. After that, we add our two other components, initiator and cross-linker. Initiator is something that begins the reaction and allow all components to combine together and make our final network. And cross-linker is something that links between the two polymers, starch and acrylic acid, to make the network. After that, after making a homogeneous solution by using the magnetic stirrer, we adjust temperature at 80 Celsius temperature in the water bath. After that, we observe that the hydrogel is formed successfully as shown in figure 6. And we wash the hydrogel and drying it and convert it into the powder form and shown in figure 8. After that, we mix the hydrogel with the nutrients in the powder form also and then distribute it on the soil.
We made a Fourier transform infrared spectroscopy, which is an FTIR analysis, in order to know if our hydrogel was formed successfully or not. So we have two figures for the FTIR analysis. Figure 9, the FTIR analysis of the acrylic acid itself, one of the main components of our hydrogel, and at figure 9 is the FTIR analysis of our hydrogel itself. So we can find that at the blue arrow at the figure 10 is the amide formation. This helps us to know that the acrylic acid and the starch and the methylene bisacrylamide was attached together successfully, and this helps us to know that the hydrogel was formed successfully. And also, in case of figure 9 at the orange arrow, this is the carbonyl bond, which is at 1707, and in the case of our final hydrogel, this peak is transformed into 1716. That suggests that the acrylic acid was attached successfully in the chemical reaction. We measured the swelling property of our hydrogel in order to know how much amount of water can our hydrogel imbibe. So we make 7 samples of our hydrogel. Each sample took 30 minutes more than the previous sample in imbibition of water, and we found that for each 1 gram of our hydrogel, it imbibed 32 milliliter of water. And this happened at 180 minutes, which is 3 hours. Also, we make this using the swelling ratio equation, and we found that this swelling property was dependable on agriculture and make a dependable product. This also at figure 12 is the hydrogel before swelling or before imbibition of water, and at figure 13 is our hydrogel after imbibition of water. That the hydrogel increased 32 times its initial weight, because as we said, for each 1 gram, it imbibed 32 milliliter of water. We make a scanning electron microscopy, which is SEM images, in order to know the morphological structure of our hydrogel. So at figure 14 is the porous morphological structure of our hydrogel, that these pores is imbibed by water, that this water is then slowly released into the plant. Also at figure 15 is a figure of about potassium molecules that attach to the hydrogel, that these potassium molecules, we already used it during the chemical reaction.
Our hydrogel is biodegradable, as consists mainly from the starch and acrylic acid. The starch is already biodegradable, and the acrylic acid is changed into polyacrylic acid during the chemical reaction, which makes it biocompatible. So the overall hydrogel is biocompatible and cannot affect the plant or any alive organism in the soil. We made an experiment to detect the amount of the effect of our hydrogel on the plant growth. So we made two groups of the basil plant. Each group has 80 sample and the two groups was cultivated in the same sandy soil, and the two groups was irrigated with the same amount of water when the group with using our hydrogel was dried. We choose the basil plant because it has quick plant growth, so we can get the results faster. And from the photo, we can obtain that the group with using our hydrogel has a more average plant growth than the group without using our hydrogel. And that's because the plant depends on the hydrogel as a source for water and nutrients, and the soil has more water retention. And we made another experiment to detect the amount of water that can our hydrogel save when using the agriculture. So we made two samples. One sample was using our hydrogel and the other sample without using our hydrogel. The two samples was cultivated in 5 days. The sample was using our hydrogel took to 300 milli of water in 5 days, but the sample without using our hydrogel takes 750 milli of water in 5 days, which means that the sample with using our hydrogel saves about 50% of the water compared to the normal cultivation. And that's because the hydrogel can save the water in the soil and increase the water retention. We test the pH of the water to know if the hydrogel affects the pH of the water or the soil, and it was 7.48 in the two conditions, which means that the hydrogel cannot affect the soil. We calculate the cost of our hydrogel to know if it is cost efficient compared to other types of irrigation. And the cost without using our hydrogel was a total $572. And the cost with using our hydrogel was a total $391, which means that the hydrogel saves about 31.6% of the cost compared to the normal cultivation. And that's because the hydrogel is already saves about 50% of the water and nutrients used in the cultivation. Compared to other types of irrigation, the hydrogel can save more water, like drip irrigation, sprinkler irrigation. The hydrogel can save about 50% compared to them.
In order to make our hydrogel in real life, we need to have a startup cost that each task of this will help us to make our project in real life. So when we calculate all the sum of the startup, we need about 35,100 in order to start our project and develop our hydrogel that will help us to make a reliable hydrogel on agriculture and expanding our production. So the question is, why our hydrogel is one of the best solutions compared to the other hydrogels used in the agriculture? This is because our hydrogel achieves 4 main criteria at the same time. That the other hydrogels only achieve 1 or 2 criteria of these criteria. So our hydrogel achieves those 4 criteria, which are the biodegradation, the simple method during preparation, and a dependable swelling property, and also it has a good water absorption capacity. All these make our hydrogel more efficient and more unique than the other hydrogels, and also we can say that our hydrogel is the future of agriculture, not just in Egypt, but in all the world.
5 more minutes. 5 more minutes.
One of the most important things is to put our hydrogel with the specific amounts according to the type of the plant and the soil, in order to make sure that there is no accumulation of the chemicals, so the chemicals could accumulate whether in the underground or at the soil, and it may harm the plant and the sand. It's also important to put the hydrogel in an appropriate depth according to the length of the roots, in order to make the root able to make the cellular respiration process. Also, at figure 20 is the figure of the basil plant and the hydrogel that we put it at an appropriate depth beneath the soil, that the plant depends mainly on the hydrogel, on the water and the nutrients. These are the references we used. And also, this is the poster that we made about our research. Thank you, and if you have any questions, tell us.
Thank you, Yusuf. Thank you, Yassine. Let's see if the panel has any questions for Yusuf and Yassine. Do we have questions? Okay, Professor Ziad, can you start?
Hello.
We will take 2 minutes for questions, okay?
Thank you for precise presentation. I would like to ask you to shed the light on the novelty of your work.
What?
The novelty of your work. Novelty of your work.
Our quality of our work?
Novelty.
Okay. The four criteria. Four criteria.
Okay. The novelty about our experiment that the hydrogel achieved the 4 criteria at the same time. That these criteria not achieved in the other hydrogels at the same time. That the other hydrogels was only concentrated on one of those, such as they are just making sure that to have a good swelling capacity, but their hydrogel are not biodegradable or not cost efficient. But in case of our hydrogel, it collects all these benefits in order to make a dependable hydrogel in agriculture. Those 4 criteria are the cost efficiency, simple method during preparation, and a dependable swelling property, and also it has a good absorption capacity.
Any other questions?
Okay.
Thank
I
you
would
for
like,
your
to thank you for
very
your
interesting
comprehensive
presentation.
Thank you.
I have a question for you. You have mentioned that you used acrylic acid in the formation of your hydrogel, okay?
Yeah.
You know that the acrylic acid has some hazards to the environment.
Yeah.
Yes.
Could you please shed the light on the environmental precautions that we should take while using your synthesized hydrogel?
Okay. When we change the hydrogel into the powder form, we put the amount of hydrogel that we put in the soil was measured, because if it is increased more than the calculated hydrogel amount, it can can be a toxic and make accumulation in the groundwater. So we choose amount of hydrogel that can be suitable for the environment and cannot affect the groundwater or affect the soil itself.
You didn't test for immobilization of your hydrogel during the experiment?
Yeah, our hydrogel degrade about takes about.
No, I'm not asking about the degradation. I'm asking about whether you included your hydrogel in an immobilized system so that you can catch the hydrogel in this immobilized technique. You can get it back, recycled, or even use it once again.
Yeah, we already recommend to make a system that can take the groundwater or take the water that we use in the agriculture to make recycle and get the acrylic acid again and make a recycle for it, and that can decrease the cost of our hydrogel and make a sustainable hydrogel.
You have anybody from your review of literature, did you find that anyone used acrylic acid in performing a hydrogel component or not?
Can you repeat your question, please?
From your review of literature, did you find that someone have been using acrylic acid in hydrogels before, or it is the first time to use the acrylic acid in hydrogels?
Okay, the acrylic acid was used before in the hydrogels. But the main thing that the other hydrogels, whether using acrylic acid with other things such as not the starch, anything not the starch, but we use the starch and the acrylic acid and combine them with each other. Also, the most important thing about our project is that we adjusting the ratios about the chemicals in order to make a dependable swelling property. That the other hydrogels using for example, a high amount of acrylic acid, but a low amount of starch or something like this, that not make their hydrogel biodegradable and have a high swelling property, but not good for the environment.
Okay, thank you very much. Thank you.
Thanks.
Thank you so much. Thank you. Thank you, Yassine. Do you have any question? Anyone had any question anymore? Dr. Salim, do you have another question?
Yes. Thank you for your very interesting presentation. I ask you if you study the effect of your hydrogel on soil moisture, water saving, or water component in the soil, and the effect of. Okay. Did you study the effect of soil of your hydrogel on soil properties?
We
Retention?
after the biodegradation of our hydrogel, we found that the hydrogel was biodegrade completely in the soil, that not changing its characteristics or even make a pollutants or something that may harm the plant or even the soil. So this was our experiment. Because we put a specific amount of hydrogel, because we don't put an excess amount that may make accumulation, and then we will have toxicity on the soil and even in the underground water.
Only, use only soil, sandy soil.
Yes, because the purpose of this, in order to make sure that we reclaim the sandy soil areas. So our main aim is to reclaim the sandy soil areas and also saving a large amount of water compared to the normal amount of cultivation methods.
The hydrogel is more efficient than the other types of irrigation that used in the sandy soil, so it has a more efficient and low cost compared to them.
Okay. Thank you.
You're welcome.
Thank you so much.
Thank you so much.
Thank you so much. Please welcome the second group of students from Ismailia STEM High School. Their topic is going to be integrated tertiary sewage water treatment via RHA for sustainable agriculture in water. Okay, let's welcome Marwan, Abdurrahman, and Ziad. You have 10 minutes and like a couple of questions afterward. Okay, that's all.
في حته لما تدوس عليها كليك عليها في السلايدات.
يعني هنا دوست عليها في السلايدات.
نعم؟
يعني هنا دوست عليها في السلايدات.
لا بنكليك حته
Oh, you
بنكليك
can
عليها.
click. No, just click.
كليك على الحته اللي هنا.
No, I don't think it's right.
زرار على في
لا أنا مش بعمل كده. لأن أنا ساعدتهم في البرزنتيشن. يلا.
نبتدي؟ أنا عايز السلايد الأولى.
أنت بتكليك بالعكس. عشان إحنا قلنا من تحت.
أمسك. Okay, أبتدي؟ Hello and welcome to Integrated Tertiary Sewage Water Treatment via RHA for Sustainable Agriculture in Egypt. My name is Abdurrahman Awad, this is Maran Yahya and Ziad Abd. Agriculture accounts for only 13% of Egypt's GDP, and yet the Nile, which is the main artery of water resources in Egypt, is heavily consumed by agriculture. This leads us to the ongoing issue that the country's per capita of water resources, which basically means the amount of water each person should have each year, is actively declining and have reached a number of 500 meter cubed per year in 2024, which is below the water poverty line set up by the United Nations. Here's a graph demonstrating the growing population, the actively declining per capita, and the water poverty line. So for that, we found one main prior solution, which is Bahr al-Bar Station. It's considered as the largest wastewater treatment plant in the entire world. It can treat about 5.6 million cubic meters daily, but unfortunately, it uses ozone as an advanced oxidant. Throughout this presentation, you'll realize why we implemented a tertiary sewage water treatment plant when we have a plant this big in Egypt.
To address this problem, it's important to understand the previous solution to put into our mind to the solution. The project which is aimed to solve 2 of the 17 of the Sustainable Development Goal, which are clean water and sanitation and climate action. The project which is water treatment through 3 stages, starting with the physical treatment and followed by the biological treatment using the aeration process, and finally the chemical treatment using the coagulation process.
Okay, we're using the physical treatment to remove the particles that can be seen by the naked eye. So we start first with the screening bars, which has two types. First type is the coarse one and the fine one. Coarse one is removing the particles like sticks and bottles, and fine one removes the thin particles. Okay, next. There's a 3 units of filtration that the water goes through is gravel, sand, and anthracite coal. The gravel one removes the particles that size of between 2 and 5 millimeters, and the sand remove particles of 0.1 to 1 millimeters, and anthracite coal remove particles of 0.4 and 0.6 millimeter. Next. Then we go through the biological treatment.
Aeration and water treatment involves introducing air to enhance oxygen levels, which supports the aerobic bacteria in breaking down the organic pollutants. The sewage water consists of two types of material, degradable and non-degradable material. The degradable materials that can be decomposed by bacteria and non-degradable material cannot. Here are the types of aerobic bacteria that helps in water treatment that locate in the sewage water. The bacteria are activated by the oxygen and the food source represented in the organic matters that are degradable material. Once the bacteria decompose the organic matter, they settle down in the bottom of the water, and it can be removed by sedimentation process.
And then we go into chemical treatment where we introduce a process called coagulation. Coagulation is a process of using coagulants, particularly natural coagulants, or particularly the silica present in the rice husk ash, to destabilize suspended charged particles so that they can form together in a process called flocculation, and by the works of gravity, they can precipitate.
Okay, after that we find that there's a sludge in the water, so to remove it we use something called aquatic blank. Aquatic blank, for example, we use the algae. Algae is used to absorb this sludge to give us a final product without any sludge. Okay, next. Why we use rice husk and what is rice husk? Rice husk is a byproduct of manufacturing the rice. So why we use it? We use it because it's a natural absorbent. As I said, it's a byproduct of rice husk. Rice, and it's very cost effective, as we find that each kilogram costs about 2 pounds of Egyptian pounds. Okay.
So how do we produce rice husk ash from rice husk? Basically, rice husk ash is a really good source of silica that we can use as a coagulant in the process of coagulation. How do we produce rice husk ash from rice husk? We get rice husk and then produce heat to it or subject heat to it at elevated temperatures in the absence of oxygen. And then afterwards, we either chemically or physically activate it to enhance the amount of silica present in the rice husk ash. There are several techniques for enhancing rice husk porosity. It involves either chemical or physical activation to enhance the amount of silica in the rice husk ash, and also absorb various ions and heavy metals and contaminants in the water. Next, is also what is the difference between biochar and activated carbon? Well, remember when I told you that we burn rice husk at elevated temperatures in the absence of oxygen? This is a process called pyrolysis, and it produces biochar. And if you want to get a maximum amount of silica, you have to activate the biochar to produce activated carbon, either chemically or physically. Next. Okay, so here is a table demonstrating the oxide composition of RHA, and it suggests that silica is a dominant part of RHA. There are also alum oxide and ferric oxide, which are both used as coagulants, or typically used as coagulants, so they help aid in the coagulation process. Okay, so what makes RHA better than other chemical coagulants? Well, first of all, RHA, or rice husk, is a very, very cheap byproduct of the rice industry. We got it for free actually from our friends in STEM Somalia school. And there's also, it produces less sludge volumes that is generally just less toxic and is easier to handle. Unlike alum, which in Bahr al-Bara station, there's an entire station just to treat the sludge produced from the coagulation. And then also prolonged exposure to chemical coagulants such as alum can lead to neurotoxicity, which can contribute to Alzheimer's disease in human health. Next. Okay, so here's the materials we use to actually construct the prototype and the methods we use in order to construct that prototype.
Okay, here are a visual representation of water after each stage: the sewage water, the water after the aeration process, and the water after the chemical treatment, the coagulation process, and the final water that we use in fava bean cultivation. The water parameters that we use to ensure from the result of water treatment suitable for fava bean irrigation or not.
Okay, to check the purity of our water, we had to measure the 4 parameters that we had said, and we find that each parameter has a efficiency of, for example, TDS is equal 52, and the COD equal 91, and BOD is 98, and pH was 2.5, as it decreased just 2 degrees. Okay.
So we did a soil analysis to the soil that we cultivated the fava beans in, and we found that the nitrogen was concentrated at about 65.5 milligram per kilogram, the phosphate about 35.5 milligram per kilogram, and then the magnesium was about 8.07 milligram per kilogram, which is sufficient for photosynthesis, nutrient uptake, and plant strength.
Okay, as we said, that's a real problem in Egypt, so we thought why we don't make it in the real life application. After calculation, we find that our total cost will be $98,000. How we calculated it? We calculated it based on global websites like Amazon and different websites. We also had to calculate the cost of each gallon, and we calculated it by the consumed materials during the process, and we find that each gallon will cost us about 11 cents. We also added the maintenance costs and laboratory costs, and this our calculation. We also calculated the flow rate of the process, and we find that our limiting factor in the process is the coagulation process, as it flow about 250 gallons per minute, and that's equal to 15,000 gallons per hour. Okay, this visualization is supposed to be pictures for the machines, but it can't appear. But those are our 4 stages of the treatment. Next. This is a visualization for the treatment, the real-life application of our project, and this is our prototype. We can say the demo of our large scale.
So there are 2 places we think that this project can be implemented in. First is Tel Kibin Ismailia and Sa'ar and Sharqiyya. So here's why we think Tel Kibin Ismailia is a good place. Well, there's a factory, a main road nearby, so that ensures easy transportation. There's also a residential place nearby so that we can get sewage water supply from. And there's a rice factory nearby so that we don't have to go into remote places to get the rice husk. Here are their places on the map. And then there's also why we think that Sa'ar al-Sharqiyya is a good place. There is a hospital proximity nearby, so that ensures workers' safety. There is a residential place nearby, and there's a rice factory nearby, so we can get the rice husk for coagulation. Here are their places on the map.
Okay, we also made a business model canvas to make it easier for the investor to know what they are getting into. And what is business model canvas? Business model canvas is collective information for the large scale application.
This is a global marketing strategy in which we encourage investors to not only invest in our project in Egypt, but globally as well. We target the markets that have water poverty and or water scarcity, which is obviously a global issue. In addition, we have a capacity for a high net margin because we produce a gallon for just 11 cents, meaning that if you were to sell that same gallon for just $1, you're going to have a net margin of 89%, which is a really great investment. Thank you so much for listening, and I wish you all have a great day.
Thank you so much. So let's open the floor for the panel if they have any questions. Do you have any questions? Okay.
It's just only one
Take
question. Didn't you do any disinfection for the water after treatment?
I'm sorry?
You didn't do any disinfection. You didn't put a chlorinating agent or something like this in order to kill any bacteria if present in your treated water?
Do you mean chlorine and ozone injection?
No. ضفت أي كلور على المية بعد المعالجة علشان لو في أي بكتيريا تكون موجودة في المية ما عملتش الخطوة الأخرانية دي؟
لا للأسف يعني آخر حاجة
لا حضرتك ما عملناهاش. احنا اصلا البكتيريا والفيروسات احنا شلناها في عمليه الايريشن، تمام. وكمان الكوجوليشن رايس هاسك هو كان اللي بينهي الحاجات دي. احنا اصلا بنفوكس ان احنا نبعد عن الكولين والاوزون عشان الكوستس بتاعتها.
اوكي ثانك يو.
Dr. Salim?
The efficiency of removal TDS was decreased by the rate of 53%, while none of your materials used in your system has the ability to remove salt, dissolved salt.
We didn't hear the question. Can you please repeat it?
Okay. TDS, your analysis represents that the TDS was decreased by the rate of 52 about or 53%, while none of your material used in the activated carbon or biological treatment or physical treatment has an effect on the salt, the dissolved salt. How the TDS ratio decreased to the half, to half?
Okay, first is TDS was 980 milligram per liter, and after treatment we find it decreased to 80 milligram per liter. So we calculated the efficiency, so concentration before and concentration minus concentration after over the total times 100 to get the percent. That's how we get that the percent.
I don't ask how to calculate the percent. I ask the mechanism of absorption dissolved salt.
I think water goes into, as I said, 3 stages: physical, biological, and then chemical. The dissolved solids actually get they wear down by physical treatment, and then biological, and then chemical. The dissolved solids particularly are removed from the coagulation process because we use rice husk that has pore structure that is able to absorb various ions and heavy metals, as well as destabilize suspended charged particles.
Thank you.
No, we have another question. Please, yes. Dr. Mohammed.
Thank you very much for your presentation. Just quick observation. You mentioned that the total cost is around 98,000 US dollars, right? Yes. How big that facility will serve? I'm talking about the small farmers. That treatment facility, if you establish one, how many fiddans, for example?
About 200. 200 فدان. It will, yeah. What?
So
no, for the whole large scale. The whole large scale it will 200 فدان.
So the cost that will be allocated for the treatment unit, 98,000, will be serving a total area of 200 fiddan.
You mean how we would produce of water or what?
No, serving 200 fiddan. The water will be treated.
The water that we will take from that large scale will be 15,000 gallons per hour.
Okay, serving how many fiddan?
It depends on how the faddans will take.
Yes, I know, but in general, the estimate. Thank you.
Thank you so much. Any more questions? Okay, thank you. Thank you so much. You can go. Please, thank you. Please welcome our next competitor, Habiba Tariq from Alexandria STEM School. Her topic is combining Raman spectroscopy and ML to detect microplastics in water. Okay.
Hello everyone, I'm Habiba Tariq from Alexandria STEM School, and I'm going to present my project, which is combining Raman spectroscopy and machine learning to detect microplastics in water. Firstly, let's go into an action that happened 2 years ago when the Minister of Water Resources and Irrigation visited a site where they used to recycle plastic and get it out of the River Nile near the Giza Governorate. They actually extracted 10 tons per month of plastic. This was a great move from them, but this couldn't solve the whole problem, since microplastics were still accumulated in the River Nile's water. Since this was the machine they used, so of course they couldn't get out the microplastics. And as we said, they got 10 tons per month of plastics. So imagine how many plastic particles can be present in this water. Now let's talk about the other prior solutions that was done before to help in the detection of these microplastics that we couldn't actually see by our naked eye. The first prior solution, which was used before, is the FTIR spectroscopy. The disadvantage of this prior solution is that it only detects microplastics which are above 20 nanometers. So it couldn't detect the whole amount of microplastics that were present in the water sample. As for the second prior solution, it was the Raman spectroscopy. This one was the most effective one used in microplastic detection, but it's problem that it's not that practical and it needs time to be processed. Moving on to the SDGs we're targeting in solving the problem of microplastics in water. The first one is good health and well-being, because microplastics can accumulate in the organs of the human body and disclaim its function. Also, we have here clean water and sanitation, because if we were able to detect the microplastics in water, we will be able to solve this and filter it and provide clean water. Climate action, because it also emits harmful gases for the environment. As for the last one, we have life below water, because also the creatures in the seas and oceans are affected by these microplastic particles. Now let's move into the most important part here, which is the methodology, or how I implemented the solution I chose for detection of microplastics. The first thing I used here was the Raman spectroscopy, which I mentioned before that is the most effective one. But in order to solve the problem that is not that practical and it needs time, so I combined this with an AI model that I've made to help in classifying the types of microplastics. And I chose this model to be a CNN model, which is convolutional neural network, responsible for image classification. I also chose it to be one-dimensional because it's responsible for detecting the graphical representations, which are similar to the spectra provided by the Raman spectroscopy. And these plastic samples shown here were the ones I used during the testing process. So let's move on to the testing process. I did 2 tests in order to make sure that this is the most effective detection way. The first one was using the plastic samples you've already seen here. I put 5 plastic samples, which are the most common plastic types used in industry of plastic containers and plastic bottles and these stuff. So they are more likely to be present in water. And they are also the 5 types of plastics I've already trained my model to classify. Then the second test was on tap water sample. These were the spectra I've got out of these 2 tests from the Raman spectroscopy I have. And now here the results of the CNN model, or how it trained and how it tested and how it was tested using this spectras. I have 3 results of 3 trials of the CNN model. The first result I've got, which is a total testing accuracy of 43%, which is too low, so I decided to provide the model with more training data and to remove any unclear data that might disclaim the function of the model. After these enhances, the model claimed a function of 70%. But the loss was too high, and as you see here in the training accuracy, the model was overtrained. So I decreased the convolutional layers, which are the layers that the model go on during the process before it gets me the output. So I decreased it from 5 convolutional layers to 3 layers in order to be trained well and not to be overtrained. After doing all these enhances, this was the final AI model results I've got, which is 87% accuracy after decreasing the convolutional blocks, as I've said. On the first test and on the second test, 90%. These are graphical representations I've also made by Matplotlib library in Python. The first graphical representation is for the evolution of the model and how it was enhanced. The first result and the second result and the third result. And the second graphical representation presents the model accuracy on the final stage. And that the accuracy is too large compared to the error. Now here, the business model on Canvas in order to implement this project. So we can make a startup for this detection system. The first thing I'm going to mention is the customer segments, which are the customers we're targeting. First, the environmental agencies, which is similar to the agency I've mentioned at the beginning of presentation. They can implement this detection way to help them solve the whole problem. And also, any large organizations that have a water treatment system, they can add this detection system to their filtration system. Also, we have the value propositions, which are the unique things we're doing through this project, which are firstly data-driven insights. We will be able to treat the type of plastics according to its type, not just treating the microplastic. So it's according to the type that the AI model will provide. And also that it will save time and effort. We will not need to get back to the spectral reference. Moving on to the future plans, which I've actually been working on nowadays. Adding a filtration system to the detection system I've already finished. For each type, of course. For example, we have the PET, the chemical, it can be solved by chemical digestion, adding acids in this stuff. And PP can be solved by density separation, adding salts, so it can float on top of the water and it can be removed. So I've been planning to do this stuff, but studying how it won't affect the quality of water. And that's it. Thank you for listening.
Thank you, Habiba, so much. Let's open the questions.
Thank you, Habiba, for your detailed presentation. I would like to ask you about the industrial application of your research.
The industrial application is that maybe the water bottle companies can use this detection system in their industry in order to make sure that the plastic bottles won't affect the water after bottling it. This is one of the applications. And any water treatment system can be added to this detection system in order to first identify the type, then can be easily extracted after that. Any other questions?
Yeah, thank you for the presentation. You said you trained your model on 5 samples, right?
Yes, 5 plastic types.
Yeah, 5 plastic components or sample. Is the model kind of constrained to a specific number which can be detected, or you can train the model for more different?
I can actually add more plastic types. I just added the most common 5 ones in order to make the model focus on them. But I can anytime add more plastics, and this is actually a plan.
Thank you for that. And the other question would be regarding the business Canva with actually the value proposition. What exactly makes you different from the other competition? Yeah.
You want me to mention them?
Yeah, just the value proposition. If you can say in one statement what makes you different to the other who could do the same.
That comparing to maybe the prior solution I've mentioned, most ways of detection now is the Raman spectroscopy. It's used alone. So they have to return back to the spectral reference. So this project can make the AI model provide us with the type without returning to the reference. So it can save time and save us from getting people who are experienced with spectra to identify it. So if the model is trained, it can be actually identified easily. So the most important thing is that it saves time and effort.
Thank you.
Thank you.
Thank you, Habiba, so much. Let's welcome the Group 4 from Red Sea STEM School. Their topic is skimmer for purifying water from leaked oils and petroleum. So we have Abdel Masih Samuel, Amr Khalid, and George Basim. The floor is yours. You have 10 minutes. Please speak.
Good morning, everyone. My name is George Basim. This is Abdel Masih and Amr Khalid from Let's See STEM. Our project is called Skimmel for purifying water from leaked oils and petroleum. So Egypt currently faces a major challenge, and this is oil and petrol leaks. Those oil can come from various sources. For example, domestic usages, commercial ships, as well as industrial facilities like factories. This caused a lot of issues for us. Number one, it decreased the amount of fresh water available for us to use in our daily lives, and it also killed fish and decreased our fisheries. Then it also increased carbon dioxide emissions. This has affected about 7.3 million Egyptians since they have no access to clean water in Egypt. And there is also an expected decrease of 20% in the per capita share of all freshwater resources per each person. And we already have an annual water deficit of 7 billion cubic meters. So our goal is to present an innovative solution that deals with this problem according to the United Nations Sustainable and Development Goals for clean water and life underwater. So such a problem definitely had people trying to solve it. Who were they and what did they do? And what sets us apart from them?
So the best solutions to this problem have been many of them, but all of them falls into three categories. First is the chemical dispersants, which is a method that uses chemical compounds to degrade oil much more faster. However, it's not effective and it is harmful to the environment. Secondly, the physical method, which uses skimmers and sponge water to degrade oil much more faster from the water. However, it's labor extensive and cost extensive. So the last method was the bioremediation, which is a method that uses microorganisms, which are natural and from the environment. However, it's not effective in the short run, but it's a long-term solution. So how did we do our solution and how did we construct it? First off, we had 3 boxes to check. We wanted to make a solution that is cost effective and functional and above all reliable and can be implemented in real life. So first off, we did a 3D model to just imagine what was in our head and to make our ideas into real life solutions. So we used also some materials that are shown in in front of you, and the total cost was 2,500 Egyptian pounds. So the prototype is shown in front of you. So what does it actually do? So first off, the leaked oil, the prototype consists of 2 parts. The anterior part, which the oil intakes into it through the pressure of the pump, and the posterior part, which is the storage container that is smart and connected to an ultrasonic sensor that detects the level of the oil in the container based on how much oil intakes into the container itself. And this ultrasonic is connected to the ESP32S that we connected it to the application that notifies the owner about the level of the oil in the storage container, which prevents high pressure on the container so that no explosion happens. So we have discussed the methodology itself, and this is the visual representation of our code and the Arduino system that we have used. So I have said efficient many times, but just don't take my words for it. Let's talk about the numbers.
Okay, this time for the test. Honestly, the test is the most important part in each type of innovation because in this point we can see success or fail of the prototype. Honestly, our test was very special because it consists of 2 categories. The first is without dynamic nozzle and the second with dynamic nozzle. And we will know what's the mean of dynamic nozzle. Without dynamic nozzle, after we said about how it works, we put it in a small pool with area about 7 square meters, and we found that there's water enters the nozzle instead of oil. We showed that this is a container that contains a huge amount of water instead of oil. Honestly, we were very anxious about this result, but we say that in real life scale we will face a huge problem. So we should think like a wise man to solve this problem with flexibility. So we overcome about this challenge with retest the prototype, but in the next time with a high observation about all the variables. all the variables that we suggest it's the problem we should replace is the nozzle. Because in the first time we use a nozzle, what's the mean of nozzle? It's the hole that enters the oil on it. It was a stationary nozzle, so if there is a disturbance or strong wave in the ocean or in the river, there's a huge amount of water enters the nozzle. So we think about our class of physics about the spring. A spring is like when the level of water increase, it also increase, and when the level of water decrease, it also decrease. So in this point, we can make our nozzle catch the water, so the oil in the above and the water only in the bottom. So whatever the level of water, like there is a strong wave, there is a stationary wave, so we intake only the oil through the nozzle. And the second point, in the first trial, we used a very strong pump with 1 horsepower. It absorbs strongly the water, so when it ties it, there is a lot of water. After replacing them, we re-notice our efficiency and collect all the variables, and we show that there's a huge increase in our efficiency. There's not everything that we did. We retest the prototype, but in this time with different type of oil, because we would ensure that our prototype is reliable in real life scale. It can deal with every type of oil. So we test this prototype with 3 different type of oil. The first is hair oil, the second food oil, and third car oil. Can you next? And this graph show the efficiency of each type of oil. We can say that our efficiency range between 89 to 90. What's the mean of this efficiency? We can say that with each ton of oil, I can absorb 900 kiloliter in just 1 hour. I say about prototype with high efficiency, very fast to deal this problem. Finally, we can say that our prototype is cost effective. In this point, we were very interested because I think every one of us, when see a high product like smartphone, very smart, very, but when we see the price of it, like, so we were very interested in this point to have a low cost, high effective, and very fast to deal with this problem. That doesn't everything that we work on it. There's a lot of modifications that we still work on it, such as
establishing a station.
Okay, we can see the video firstly. ممكن حضرتك تشغل الفيديو؟ Okay, no problem.
So our future plans are establishing a station that is able to deploy a unit to where the oil leaks, to where the oil leak is. The second thing is we want to, that oil that we collect, we want to recycle it to be able to either reuse it or sell it to maximize our profits. Then we also want to utilize more forms of clean energy. As shown in the picture of our prototype, we only used solar energy, but we're also planning to use hydroelectric energy. Finally, then we want to be able to locate the spills. With the help of the GIS, we can locate where the spill is to deploy a unit that is capable of going there and returning back with the oil. Finally, we want to make an oil separation mechanism, because when we collect the oil, we collect each type of oil combined. So we want to separate between each type, and we can use a sensor called the viscosity sensor that is capable of doing this to our well in the station. So something like this project needs a plan to be able to be implemented in the real life.
Hi again. In this point, everything in our life is translated into monies. To produce this prototype in real life scale, we should to study it successfully. So we had a large business model, but we summarize it in the most important parts. The first, who is the supporters? Honestly, in this time, we search about the supporters that can fund us or our prototype to make the first unit of our prototype. The second, who are the customers? Honestly, we have two customers. As I said, we are from Red Sea, so we have a lot of companies of petroleum. So the first one, we know that the authority in last years restrict rules for every owner to have a plan A if there's a leaking of oil or petrol to solve this. So in our prototype, we combine with these companies. We say that we are a plan A for you. If they're leaking from your companies, I will solve this problem and come back with your oil and give you it again. Finally, our cost. In our cost, as we said, in small scale, we paid 2,000 Egyptian pound. But in real life scale, how we will pay and how we will gain, we will pay about 7,000 Egyptian pound. How we calculate it, that with companies of petroleum, and it is estimated number. Finally, how we will gain? In the first year, as we said, we use solar energy. In the first year, maybe I will pay a lot of money, but finally, I will gain, or my income will be increased. Finally, that's all the point that we will overcome our prototype.
Thank you so much.
Okay. Okay, do we have any questions for the panel?
Thank you.
Any questions? Dr. Ziad?
Thank you for your attractive presentation. Actually, I would like to ask you to explain the commercialization challenges for your prototype.
Can you again?
Commercialization challenges of your prototype. Tasweep.
Okay. The first, as I said, there's a lot of companies that work with the same idea of to solve the petroleum. But when I will enter the market about our prototype, I will find the competitors. But honestly, I studied marketing in HP, so I have a lot of strategies to deal. So I think that the most challenge that I will face the competitors. But as I said, if you, the owner of company, when you will see that my price, my efficiency, my fast to overcome this challenge, you will deal with me.
Thank you so much. Any other questions? Okay. Do we have questions? Okay, thank you so much. Thank you, George. Thank you, Abdel Masih. Thank you, Am. And now for the time, we have the last STEM school from Ismailia STEM School. The title is Smart IoT, based on the irrigation system for efficient water management agriculture. Please welcome with me Mohammed Ayman and Bad Tamer from Ismailia STEM School. Okay. You have 10 minutes to present.
Ladies and gentlemen, welcome. It's our pleasure to present to you today. Okay, firstly, I would like to introduce myself. I'm Mohammed Ayman, and this is my friend Badr Tamer. We are students from Ismailia STEM High School, grade 12 students. Firstly, our project under the title of Smart IoT-based irrigation system for efficient water management in agriculture. Okay, as you know, like 70% of the fresh water amount in Egypt are used in only agriculture. Okay, also there are other traditional methods of irrigation like that causes water crisis and wastewater in even if it's over irrigation or under irrigation. So our purpose of the project is how to deal with the project of efficient water management in Egypt and how to deal with this problem efficiently and with applicable project. Then that's our problem statement. Then the target SDGs. The first one we have like the climate actions. how to deal with a sustainable climate and how to make, like what I said, like a project achieving the sustain in the environment with a high efficiency, and the other one is responsible consumption and production. How could we affect the agriculture and the crop yield point in Egypt, and how can we increase its efficient also? Okay. Our solution.
Talking about our solution, we are here to develop a system of drip irrigation. As we know, drip irrigation saves and conserve water from about 30 to 50% of water. So we try to increase this efficiency, and we just increase it for 70%. Our solution, which is merging IoT with agriculture. As we know, agriculture is very considered as a very important thing in our life. We try to increase this crop yields by monitoring the environment of the plant and watering the plant with automated system. Started with our system. At first, the listed of components, the hardware components, this is the price of hardware components, which is 825 pounds. The hardware components only of the prototype. الفيديو بروتوتايب لا مثلا ماشي تمام خلاص كده ماشي بس تمام. Talking about our main parameters, it started with the soil moisture. Soil moisture, we're using a sensor which is measures the content of water that found in the soil, that only that can be traveled in the plant to the plant. The second and third parameter, which is temperature and humidity. We are not here only to watering the plant. We are here to organize the environment of the plant and improve the crop yields and the health of the plant. And the least parameter, which is the water usage, we use water flow sensor. The water flow sensor here, which to be accurate in sensing and using how amount of water that be used in our system and conserving water. Talking mainly and walk through our functional prototype. The projects are connected on PCB board. The red light, which is the power. Light color, which is the water pump, is working. Water pump started to work. LCD screen monitoring. Here, water pump starts to take water from the tank and to the soil according to the some moisture details we have sent it in the some moisture sensor according to ESP microcontroller. This is our development prototype at the end. As this is a PCB board design. The PCB has a visual light, visual LEDs, and the LCD screen monitoring all of the details. Soil moisture sensor to measure the moisture of the water. DHT measure temperature, humidity. Upper side, which is rain sensor, as we use the rain sensor if the rain fall. If the rain fall, it started to open the tank using servo. There is an ultrasonic waves radiation to know how is the level of the water. Water flow sensor we combined with Arduino Uno to know how measure and how liter of the water have been used. At the end, the MQ5 sensor. The MQ5 sensor, which is used to detect harmful gases. The harmful gases here, as we know, a plant can be sided with harmful gases as the factories are gradually being everywhere nowadays. So the methane and the carbon monoxide, which is harmful gases for plants. So we want to solve this by using a gas repellent, a fan which used as a gas repellent to take out the gas and making a new air for the plant. Next. Starting talking about an agri-tech, which is mainly our solution, prior solution.
Okay, our main prior solution was organized firstly by the Administration of Irrigation and Water in Egypt. Agri-tech project, it was a project integrating traditional agriculture with the technology based on the smart systems. The vision of this project, starting by 2022, to have discovering what are the basics of agriculture and how it could be improved, and by having like a vision by 2028 to have like a complete systems and to know how exactly these systems and smart IoT can affect the irrigation in Egypt. Okay, that's like two figures illustrating our project and how to be with these privileges. Okay. The second slide of AgriTech. Now we're going to talk about our main like IoT platform and how we visualize the data.
The IoT platform, as we don't want to be as usual fields to the farmer which has been work. We want to make things more easy on the farmer. So all of this data are connected on a platform which is called Blink IoT. The Blink shows the data visualized. Also, we can control manually all of the systems. This is screens for how does the platform works. As second, we don't only main on the platform to show the data. We also use a WhatsApp bot, which is called the Call Me bot. This WhatsApp bot send every action happened in the system to the farmer and makes an alert for everything happen. And if disorder having in the system, it starts to send alert by detecting harmful gases, the rainfall, and filling the tank. All of this have been sent for the farmer. Starting talking about the results. To make an accurate results for these systems, we have measured it in 3 seasons, but this time wasn't available for us before the conference. So we started to make a simulation for these 3 seasons, but building a greenhouse. This greenhouse simulates the summer, winter, and spring as we get it and put the system inside it and put it on the perpendicular to the sunlight rays. It starts to get all of the light rays. Sorry, it starts to get all of the light rays and affected it on the plant. So it appears as we are in summer, and for the winter, we put it in an air-conditioned room and starting working this fan. This fan mainly has 2 functions. At first, which use as a gas repellent for the MQ if the harmful gases get for around the plant, and also we use it as a simulation for the winter as we open it to decrease the temperature for the plant and simulate that we are in the winter. And the spring, which we can say that is the normal room temperature. We started to taking all of this analysis and get it on the graphs. The graph shows the temperature and the humidity, also the soil moisture, according to different 3 simulations that we do. Another charts. The efficiency calculation. We started to know how efficiency or how conservation of water that we have been used. The conservation of water that used, which was 70%, we know that drip irrigation saves around from 30 to 50% of water from other traditional irrigation. So we increase this percent to 70%, and this percent can be increased more and more on the larger scale. So it was a very massive efficiency for conserving water from this system. Visual data for every LED and every LCD screen that can be showed in the system. Starting with talking about the larger scale.
Okay, let's discuss some different things in our large scale, which is the most important thing on our project. Okay, firstly, we published 2 versions of our large scale. Our large scale can be published on the first version, which is farmers version. This version is actually for the simple farmers or small farms. This version can be applied on a space of from 1 to 8 acre فدان, and this version have some privileges or benefits we can deal with, like it's simpler to deal with the farmer, as most of the farmers have like a base knowledge with technology, so it's easier to deal with, and a more economic, low budget cost, and also it's connected with an AI. It's not it's not a reduced package. I mean, okay. The second one, which is operation. The operation version is like the original version or the basic version, but only it's for a larger acres or fedans, okay, and also it have like some more sensors, so it can give us more accurate measurements. Especially it's aimed to the research centers or the operations, and that's an illustration video showing how it can be applied for the operations from the main control unit and the field unit, and how the farmer or the operation center can control by a distance, okay. That's our mobile user interface, and then we will illustrate like the farm and the water tank and how the field with the drip irrigation will be moved on. Okay, and that's the drip irrigation method, and that is the ending of the video, and there's some privileges of our project, like the high efficiency, low cost, and some in dealing with simple farmers with simple base knowledge. Finally, we have like a large-scale pricing for the farmer version. Okay, this is the sensors and the microcontrollers with all the prices. Like we can be calculated approximately totally at the end with starting from 8,500 Egyptian pound. Okay, in order to like this cost estimation, like as I said, it saved like 70% of water than traditional method, and we have our own clouds or software system, and finally it applied the low energy consumption concept. Okay, and to sum up, we done like a small research for how to recycle water, or to start from scratch with having the untreated water.
We worked on a research before. This research was about wastewater treatment. It started with bar screen for removing large particles. After that, a grid tank slowed down the velocity of the water and started to deposit all of gravels and sand, sludge and scum, deposit and scum float. After that, the aeration tank, which about giving air to the water to start increasing the organic matter in the water. After that, coagulation using silica materials. In this, we discovered a new way to get the silica out from the rice husk on the large scale by using pressure, not to using temperature. At the end, we mentioned this as we wanted to merge this with the operation systems, as knowing that the operation system need more electricity and need more sufficient water. If there is no rain if there is no electricity, it can be more energy consumption. So we mentioned that as we have biogas, and also we have water which has been treatment for agriculture, so it can be a fine merge for more accurate system.
Thank you so much.
Thank you.
Mohammed. Thank you so much. Any questions? Do we have any questions for the students? So, Mohammed, you want to say just a small comment?
Yeah.
Very quickly.
Very quickly, I was saying like it's a pleasure to present you, and sorry for bothering you. Okay, thank you.
Thank you so much. And now it's time for announcing the winner. Thank you, guys. First, I would like to thank all our competitors today. They did a great job. You have to be proud of yourself. Now we're just like taking a couple of minutes for the judges to come up with their grading, and now it's like 1 or 2 minutes, and we're going to announce the winners. Okay, can you please be seated? So now it's time to announce the winners. We're going to start with the 5th place. Are you ready, everyone? The 5th place will go to the Integrated Chari Sewage Water Treatment via RHA for Sustainable Agriculture in Egypt. It's Abdurrahman Awad and Ziyad Mohammed. And we have Marwan Yahya. Dr. Ines will handle the certificates. Can the panel, can they take a picture with the panel, please? If you can step up, please. much. So now we have the first place. And the fourth place will go to Yusuf Abdelal and Yassine Yasser for the sustainable agriculture irrigation using bio-based hydrogel. Do we have the fourth place check, please? Thank you so much. And the third place goes to Habiba Tariq for combining Raman spectroscopy and ML to detect microplastics in water. And now for the second and the first place. Are you ready? So the second place goes to Abdel Masih Sameh, George Basim, and Amr Khalid. Their project skimmer for purifying water and from leaked oils in petroleum. Congratulations, guys. Thank you so much. And now for the first place goes to Ismailia STEM School, Smart IoT-based irrigation system for efficient water management in agriculture. Congratulations. Thank you everyone for attending our session today, and congratulations for all the teams for joining the Young Water Inventor, and see you next year for the Cairo Water Week 8th edition, inshallah. Thank you so much for the panel from Dr. Ines, the chairman, Dr. Safa, Dr. Ziad, Dr. Mohammed Yaqub, and Engineer Mahmoud Ali. Thank you so much.